In this course, we're going to discuss the different ways that the user interface can be set up in VR and some best practices to keep in mind. Then, we will set up the UI in our game and test it out. The distinction between user interface and user interaction is a blurry one in VR. In our experience, projects that avoid using a lot of text are more successful. This has to do with the current limitations of screen resolution in consumer headsets. For instance, if you're making a baseball experience, it's better to go into the locker room and pick out a bat than to open a menu and pick it from a list. That being said, sometimes there might be too much information to portray naturalistically, and other times the production time to naturalize every choice will be too cumbersome. Fortunately, there is sophisticated UI development capability in Unreal Engine, Unreal Motion Graphics, or UMG. The trick is to use it as efficiently as possible so that it doesn't bog down the frame rate. Even if you only have a small amount of UI, you should run it efficiently to save on power and extend battery life. Each UMG widget uses a render target to draw components to the screen, meaning with every widget comes render performance and memory impact. There are two main mechanisms for rendering conventional UI, things like text, boxes, and buttons. The first way is to use isolated elements that float around in the world. The second is to render the UI to a texture. In this case, it is used as a render target, and then this texture will get drawn onto elements of the world. Which method we should use will depend upon the individual needs of the project. For example, if text is going to be a few words or sentences only in your virtual world separated from other pieces of text, the better choice would probably be to use an isolated text render actor. However, as the amount of words, boxes, and elements increases, it's more efficient to use the render target, which is where UMG comes in. This will take you a bit more time up front, but yield a great amount of performance that could make or break a program. Speaking specifically to Quest developers, this is especially important for Quest as the draw calls need to stay below 150 per frame. There is also another option, to use a VR stereo layer. Stereo layers render in parallel to the world of your game engine, allowing you to send a separate texture to the VR head-mounted display, and have it re-projected in a separate rendering pass than the rest of the project. While they are a helpful feature for VR projects, it's important to remember that they can also be difficult to manage and mix with the rest of your 3D content. This is because of stereo convergence, where two objects are rendered in two separate planes while existing in the same screen space. This can quickly cause eye strain. You might want to have a fallback method to see the content without a headset, or have the UI elements completely envelop the user's view. After we get all the UI on the screen, we will immediately need to be able to interact with it, so you're going to have to decide how that interaction paradigm works. UI decisions have a direct impact on user experience with any type of content, but especially in VR. Do you want to cast out beams from your controllers in the virtual space and use them like mouse pointers? Or are you going to have to touch the elements with your fingers? You could even create a framework whereby users interact with elements simply by looking at them, which isn't as common in real life, but is actually super easy to program in VR. In fact, this simple mechanic is exactly what we used in the setup of BP Dart from the previous course. You can easily replicate that for a VR pawn mechanic. And from there, whatever you choose will elicit new interface and interaction questions. Another thing we need to consider as you press into a 3D button, your finger won't meet resistance the way it would in the real world. How can you convey that press sensation? And do you want the controller to vibrate to give some sort of haptic feedback? The best way to answer these questions is to think through how each might align with the goals of your app. In our experience, developers will aim for elaborate three-dimensional UI designs, but eventually, through testing and optimization, they end up using a simpler flat design for their UI. It's worth thinking through this early because it will save you time on the back end. We also have the option to attach UI elements to the player camera. This creates a virtual heads-up display, or HUD. HUD elements that are nested within the camera's hierarchy in the player pawn automatically inherit the camera's transforms, keeping it welded in the HMD's screen space. Because these HUD elements will live directly in front of the user's face, their placement needs to be considered carefully. Text elements are more difficult to read the further they get from the center of the screen, and it is best to avoid rendering text data close to the edge of the screen in the first place. You have to consider the screen as an extension of the user's eyes. If you render text too close to the screen, you will cause eye strain, as the user will be trying to move their eyes to read the text in the corner of their vision. Imagine how uncomfortable you feel trying to see something just on your periphery for extended periods of time. Now imagine having to do that during gameplay. The HMD may be utilizing fixed foveated rendering, or FFR, to sustain a fast frame rate. This can cause another problem, as the edges of the screen will be rendered at a lower resolution. FFR can be set to different intensities, so based on the performance needs of your application, placing text near the edges of the camera may make it impossible to read. Hood elements can be added to your pawn in multiple ways, the simplest of which is applying a render target to a masked material on a simple plane attached to the camera, or we can create a custom mesh that takes advantage of stereo rendering, giving the UI three-dimensional depth. It's best to keep your hood materials as simple as possible, unlit with the fewest numbers of instructions possible. This is because, again, hood elements are so close to the camera that they occupy a large amount of screen space. Welding UI elements to the camera can feel a bit jarring to some players. You may also want to consider smoothing the transforms in a loose follow behavior, which will slow the movement of the UI, giving the sensation of weight. In this case, instead of nesting elements to the player's camera, we actually want to read the location and rotation of the player's head and interpolate a new location for the UI to use. This happens on a per-frame basis. It's possible to define the rates that objects interpolate separately. This would allow a rotation to have a separate rate from location. Later on, we'll discuss the solutions we'll build for our Dart game, but first, having now discussed UMG, in the next course, we'll discuss using text-based UI.